Eh, Is it weird how these smartphones have become like an important part in our lives? I mean, look at you. Look at you guys. You guys are glued to your screens.
But have you ever wondered how touch screens actually work? Like it's just glass, right?
Oh, that's a great question. You're always curious about this thing. Funny enough, touchscreen actually works because of quantum mechanics. Ever heard of it?
Wait, quantum mechanics? Isn't that like super complicated science about particles and stuff? What does it have to do with my phone?
Oh, I know this one. It's got to do with something called capacitive touch. Wait, let me explain. You see, when you touch a screen, your finger acts as a conductor that will create a disturbance in the electric field. The disturbance is then detected by the grid of electrons beneath the glass surface. But what's really interesting is how the electrons behave at such small scales. At the quantum level, the electrons don't simply move, but instead, their movement is governed by probability and quantum interactions. When your finger touches the screen, it alters the charge distribution, triggering a rapid shift in the electrical signals. This shift happens almost immediately thanks to quantum effects that allow electrons to move efficiently through the material.
Exactly. Let's break it down a little bit more. Touch screen is the principle of quantum mechanics called electron tunneling, which is related to the behavior of electrons at atomic level. Here's how it works.
Modern touch screen use something called capacitive technology. Underneath the glass surface, there's a grid of conductive material, usually indium tin oxide, ITO, which is transparent and conductive. When you touch the screen, your finger, which is also conductive, alters the local electric field, charging the capacitance at that point.
But some advanced touch-sensitive material like quantum tunneling composites (QTC) work differently. Unlike traditional capacitive touch screen that rely on static charge redistribution, QTC-based material respond to pressure. When pressed, the microscopic conductive particle within the composite move closer together, allowing electron to tunnel through what would normally be an insulating material.
Wait, where does quantum mechanics fit into this?
Good point. Actually, the concept of quantum tunneling helps explain how these electrons move so efficiently in these conductive materials.
Right! Quantum tunneling is a phenomenon where electrons can pass through a barrier that would normally block. Quantum tunneling is a phenomenon where electrons can move through an energy barrier that would classically be invisible. Imagine rolling a ball up a hill. Normally, it wouldn't have enough energy to cross to the other side. But at quantum scale, electrons don't behave like tiny balls. Instead, they exist as wave function, meaning their position isn't fixed until they are observed. This is where things get interesting. Instead of needing enough energy to climb over a barrier, electrons have a probability of appearing on the other side, as if they are teleported through an obstacle. This is quantum tunneling.
However, QTC-based touch interface take this a step further by using quantum tunneling composites, or QTCs. These materials contain nanoscale conductive particles suspended in a flexible polymer. In their normal state, the particles are far apart, meaning little to no electrical conductivity. But when pressure is applied, the particles move closer together, allowing electrons to tunnel between them. This tunnel effect causes a rapid and exponential drop in electrical resistance. The more force you apply, the easier it is for electrons to tunnel, making QTC screens highly sensitive to pressure variations. Unlike traditional capacitive touch screens, which only sense position X and Y, QTC-based screens can detect how hard you press, adding a third dimension control.
Wow, so every time I swipe or tap, I'm basically using quantum mechanics.
And the cool part is, touch screen not only detect where you touch, but also how many fingers touching it and its gestures. This precision is because of how accurate we can control electron behavior inside this material.
Wait, I just thought of something. The way touchscreens detect multiple touches at once, that's related to capacitive charge, right?
Yes, totally. Do you want to explain how that works?
Sure! So, a capacitor is like a tiny battery. It stores electrical energy by holding opposite charges on two conductive plates. But at the quantum level, the capacitors work because of quantized energy levels. electrons don't move freely, but they occupy discrete energy states. When you touch the screen, the capacitance changes because your finger alters the electron density at specific points. This is crucial for multi-touch technology. The screen isn't just sensing one big change, but they're detecting multiple individual shifts in capacitance at once. Thanks to quantum effect, the touch screen processor can rapidly distinguish between different touches, even if they happen at the exact same time. For pressure-sensitive touch screens, QTC take this further. Instead of just detecting where you touch, they can sense how hard you press by measuring the quantum tunneling effect between conductive particles. This allows for variable input, like pressing lightly for a soft stroke or firmly for a bold line in a drawing app.
That's a great way to put it, Daya. And plus, the quantum behavior of electrons ensure that these tiny changes in charge are detected quickly and precisely. That's why the screen feels so responsive.
I'm blown away! So quantum mechanics doesn't just live in the lab, fancy equations is literally in my pocket.
Absolutely, and it's not just that screen. Quantum mechanics is actually behind a lot of modern tech, like semiconductor in your phone's processor and even the LEDs in your screen.
Yeah, that's right. Scientists are working on quantum materials in order to make touch screens more thinner, more sustainable and more efficient.
Now I feel like walking quantum experiment every time I use my phone. It is fascinating!
So, the next time you tap, swipe, or scroll, remember the incredible science behind it. Touchscreens aren't just an innovative engineering. They are a proof to the power of quantum mechanics in our everyday lives. Who knew that science could be so touchable? That's all from us. Thank you so much for watching and have a nice day. Bye!